Hey, what's up everybody? Welcome back. Today I got this package in the mail and it was sent from a viewer. It's a Peavey Transfex Pro 212S amplifier. Obviously they did not send the cabinet. It would have cost too much to ship the cabinet because it's got two 12-inch speakers in it. So they only sent me the head. So I'll have to hook up my own speakers and try it out. The complaint with this amp is that you turn it on and it gets stuck at the startup screen. Nothing works, no sound comes out, it just freezes on the startup screen. So we'll have to take a look at it and try to figure out what's wrong with it. They also told me that a couple years back the NiCad battery in here was leaking. This does have a NiCad battery to keep the static RAM going when you turn off the power. And that battery was leaking, and they took it to an amp tech where they got charged over $100 to replace that battery. And they got it back, they turned it on, and it does the same thing. It gets stuck on the startup screen. So we'll have to check it out and see if we can figure out what's wrong with it. So yeah, this should be interesting. Let's get this on the bench and see what we could find. Alright, I got the amp on the bench, and we're going to turn it on to see what the problem is. And I noticed here there's one of the fins is bent on the heatsink. I don't know if that happened during shipping or if it was like that. Also in the back over here, if you look back here, one of the external speaker, the right external speaker output, there's a nut missing, and it looks like the jack is bent. So I think it was like that because the nut is missing. So all right, I'm gonna turn it on so we can see what it does. All right, guys, don't do what I'm doing unless you're an amp tech and you know what you're doing, because there are high voltages in here. You could get hurt. You could even get killed. It's not a tube amp, but you still have high voltages. Okay. All right, so I got it going through my isolation transformer, and let's see what it does. Okay, I heard the relays click, and nothing's happening. Okay, just like he said, it's just stuck on this screen here. And you can't do anything. So, all right, let's try to figure out what's wrong with it. All right, guys, so here's the amp. And so the story goes with this amp is the owner took it to a tech because it was having the same issue that we just saw. And the tech replaced the battery because the original battery was leaking, the original NiCad battery. He replaced it, cleaned up the board, put a new battery in it. The owner then took it home, turned it on, and it had the same problem that we just saw right now. So the battery was changed, but that didn't solve the problem. So maybe there's still damage on the board that wasn't cleaned here. Okay, so we have to look at that and try to figure it out. All right, guys, I just took a closer look at this new battery here, and there's corrosion right here. Okay, I don't know if you can see it. Right in there, it's leaking. Okay, and it's also leaking on the backside. So something's wrong with this battery. Let me get my meter so I could check the voltage on it. All right, put the meter right there. Zero. Wow. Nothing. Let me check the resistance. Maybe it's shorted. No, it's not. It's not shorted. Okay, but the voltage is 0. Yep, 0.3 actually. Yeah, this battery's dead. So we got to figure out why this battery's dead. It's a brand new battery. This shouldn't be dead. So let's take it out. I think I'm gonna take it out and have a look at the board. I'm gonna remove this whole board and try to figure out what's going on. Alright guys, you're not gonna believe what I just found here. This is your static RAM right here. okay? And the whole reason you need a battery is to power this static RAM, because this is volatile memory. So that means when you turn the power off, this gets erased unless you have a battery, okay? So the battery is there to keep this so it doesn't lose its contents when you turn the power off, okay? The original battery had 2 pins for the positive and 1 pin for the negative, okay? Now, if you look at the ones I got here, they have 1 pin for the negative, 1 pin for the positive, same as this one, okay? And you can use those in here, okay? That's fine. The reason they got 2 pins probably on those, the original ones, is because the board is not marked, so you'll know which way to put it back if you replace it. Now, when I look at this battery here, knowing that the positive one, the original battery, the positive had 2 pins, there should be 2 holes in the board here, okay? Let me zoom in. All right, let's see here. Right here, there's 1 hole, okay? There's nothing here, okay? You see that? All right, but if you look on the back, see if I can zoom in, you got 1 hole here where the pin is going into, and another hole here, okay? I don't know if you can see that, but there's another hole there. So what does that mean? That means this battery was installed backwards. The positive side should be where the 2 holes are. The negative side should be here. So that means we're going to have to remove this whole board, okay? And take the battery out, put a new battery in the right way, and clean up the board, and let's see what happens. And I don't know if you can see this right here. Looks like they drew a plus sign with like a silver marker or something. But they got it wrong. This is the positive side, not this side. So it's backwards. Alright guys, here is the board, and it's in pretty good shape actually. It's not too bad, except for the battery, and you can see where it leaked right here, okay, and on the back, okay, and right here on the back, you can see right here, this is where the 2 holes for the positive terminal are. There's 1 right there, okay, there's nothing in it, and there's 1 right there where the pin is. So that's 2 holes. This is where the positive should be. The negative should be on this side where there's 1 hole. Okay, and let's look at the back. Yeah, they put a jumper across the 2 holes. You don't need that jumper because there's a trace here. See that green trace going in there, connecting the 2 holes? Okay, so we'll remove that jumper and remove the battery and replace the battery, and we'll put it back in and try it out. Alright, I got the old battery out, and the board looks pretty good actually. So here it is, all cleaned up. There's the holes for the battery, the 2 up here for the positive and 1 here for the negative. Okay, here's the back. There's 1 and there's the 2. Alright, so the board looks pretty clean. The previous tech did a good job at cleaning it. They just put the battery in backwards, but we all make mistakes. So here is the new battery that I'm going to use right here. Okay, and let's check it really quick. Make sure it's good. Okay. Oops. 3.938 volts. Okay. So it's higher than 3.7, so it's fully charged. So it's a good battery. Okay. Now, before we install that, I want to make sure that these connections near the battery where it leaked are still good. All right, let's check for continuity. So let's start with the battery connections. The two holes where the positives are should be continuous. That's good. Okay. The back side, same thing. Okay, that's good. Okay. Let's see. The ground of the battery, and I'm gonna check on the ground, see if it's continuous with the ground of the static RAM, and it is. Okay. All right, let me get the schematic so we could check a few more things here by the battery. All right, so here's the schematic, and here's the battery right here. Okay, and you can see it goes into this resistor. Okay, and that is that's R510. Okay, so it goes into this resistor, and then it goes into V back, the backup voltage, and that's for the static RAM right here, V back. Okay, because remember, this battery powers the static RAM. Okay, and this circuit here, that's this op amp right here. It uses a comparator to check the battery voltage when you plug it in to make sure the battery's charged, and it charges the battery basically when this unit's plugged in. Okay, so we want to make sure these connections are here. So what I want to do is check R510. It should go to the positive side of the battery. Okay, and then the other side of R510 should go to V back. So it should go to the power of the static RAM. So let's check that. All right. So here's the positive of the battery. Okay, I'll use this one. And then this is R510. Okay, so that's connected. So the other side of R510 should go to the power of the static RAM, because that's the V back. And that's connected. So I think we're good. I think these traces are good. So I think we should be okay. I'm just going to put this back in the amp. First I'm going to install the battery and then put it back in the amp, and we'll try it out. All right, let's put a little hot glue here. Just a little bit to hold the battery down. Okay. And then we'll put the positive side here and the negative there. Okay. Make sure we get it right. And that's it. Should be good. All right, let's not forget to solder it in. Okay. All right, let's check the chip, the power across the chip. Here's the VCC, and here's the ground. 3.878 volts. So this battery is now powering the static RAM. So that's good. Let's put it back together and see if it works. All right, guys, I got everything back together with the new battery, and I'm going to turn it on, and I'm going to do a factory reset while I turn it on, and you do that by pressing the down and the right arrow. Okay, so let's turn it on. Okay, it said memory initialized, and it went back to this screen, and it's stuck. So changing the battery didn't fix it. Okay, so we're gonna have to do some more troubleshooting to figure out what's wrong with this. All right, guys, so here's what I'm thinking. There's 4 parts to this amp. Okay, you got your power supply right here. You got your digital and your preamp, both on the same board. Okay, it's the digital stuff and the preamp. And then you got your power amplifier back here, okay, these transistors. Now, I think the problem is on this board somewhere, the digital or slash preamp board, okay? But it could be in the power amp section, okay? So I don't think it's in the power supply, but we'll check that later. But what I want to do is check the power amp, because if we have a problem in the power amp, these transistors are very expensive, and I'm going to have to let the owner know. So I want to check this to make sure there's nothing wrong with the power amp, because I already know there has to be a problem here somewhere, okay? So, and here's how we're going to check this. Let me show you. All right, so if you look in the back here, okay, let's see if I could get back here to show you. All right, so you have the bottom set of jacks. You have power amp in, preamp out, power amp in, and preamp out for the right and the left channel, okay? So we're going to use those to test the power amp, and I'll show you in a minute how we're going to do that. All right, here is the amplifier for this amp, okay? That's this whole board right here, okay? And what we're going to do is, let's see, this is the left channel. No, this is the right channel, and this is the left channel. They're both the same. So we'll just look at the bottom side, okay? And we're going to focus on this part right here, okay? These are the 4 jacks I just showed you in the back. So you got your preamp signal, okay? The right coming in here from the preamp, okay? That's a different section. And then the left coming in here, okay? So the signal from your preamp comes into here, okay? Goes down here, okay? And this is your preamp out jack that we saw in the back, and this is your power amp in jack. Okay, so the signal comes from the preamp, goes down here, and goes here, okay, and into the power amplifier. And notice how the volume control is here, okay, and then you have some other controls here. You have the dynamics, the presence, okay, that's all these things in the front here: volume, presence, and dynamics, okay? So, okay, the way this works is the preamp signal comes in, goes down because they're connected, and then goes into the amplifier. So if I plug something into this amp jack, I'm breaking this connection. So the preamp signal can't come in to the amplifier anymore. But since I'm plugging in something here, I can bring in the signal from here. So basically what this allows me to do is plug in a preamp, an external preamp, and send the signal here and see if the amplifier is working. All right, so that's what we're going to do. And the left channel works the same way. So I'm going to get one of my preamps. I'm going to plug it in the back, okay, into the power amp input, and we will see if the power amp, if the amplifier part, if this section right here is working. And we should be able to control the volume and everything using these 4 controls. Now, if that doesn't work, then that means the amplifier is broken also. So let's do that. All right, guys, we're ready to try this out. I've got 2 8-ohm 12-inch speakers going in where the regular speakers go for this amp. Okay, I got my ADA preamp all hooked up to the power amp in, and we're going to try it out. All right, let's see what happens. All right, here we go. Let's power on the preamp. Okay. And I'm going to turn down the volume and everything here. Okay, and let's turn it on and see if it works. The amplifier works. It's a little noisy, but that's my ADA preamp making the noise. So it seems like all these are working and the amplifier section back here is working. So the problem is probably on this board here. So let's take a look at this board and try to see what's going on. All right, guys, I had to take the board out again, and I took the battery out. I removed it because we got some major issues right here. Okay, some of these vias have so much corrosion in them that they're clogged, and they're not going through to the other side. So let me get a close up so I can show you what I'm talking about. All right, here's where the battery goes. Okay, and let's look at this first right here. Okay, there's a via right here that goes to the bottom of the board. Okay, and I don't know if you can see this, but from here there's a trace that goes right here onto this capacitor from here. Okay, so let's see if we have continuity. Okay, so from that via to the capacitor, nothing. Okay, there's nothing here, and it's because the corrosion has destroyed this via. Okay, now if I look on the other side of the board at this via, okay, let's look at it. That would be this right here. That's the via right there, and that goes right here. Okay, right in here there's a voltage regulator. Okay, let me show you. That's this right here. It's a voltage regulator. That's supposed to bring power to this via right here, but it doesn't because it's broken inside the hole from the corrosion. Okay, that's one issue. Okay, all right, another issue is right here, this resistor. Okay, there's a via right here. Okay, let's look at that one. Okay, this is a 47K resistor. All right, that via goes to this resistor. Okay, it's going to the pad. You see that? It's connected to the pad, but the pad, look at that. The pad's not connected to the resistor. It's not making contact. Okay, and that's an important connection because that also goes up here. Okay, and this is part of the battery charging circuit. Okay, so we have to fix that connection also. This is broken right here. So now that's two things I found. There could be more, so I'm going to go through it and fix these, and I'll show you how I fix them. Okay, all right, everybody, before I could do anything, I found another problem. As you can see here, I had to remove this chip to figure it out. So it turns out that this via right here, okay, this one right here, I was testing it and it goes under this chip. That's why I had to remove the chip. But if you go underneath on the other side of the board, it's going to this regulator. Okay, right there. Okay, it's making contact. It's going under the board. The trace goes into this regulator. Now it's going into the unregulated side of the regulator, not the regulated side. So this is a 5-volt regulator, so that voltage is going to be 9 or 10 volts, okay, because it's unregulated. Okay, now from here, okay, as you can see from right here, there's a trace, and if you follow that trace, it goes right here, okay, in this via right here, okay, and then this one under the board, if you follow it, it goes to this diode. Okay, this is a Zener diode. It's a 5.1 volt Zener, so it takes this unregulated voltage, converts it to 5.1, okay, and this is what supplies the battery circuit, okay, the transistors that control that circuit, the startup, host startup when the system starts up, and the mute circuit. So this does a lot of stuff, okay. Now the connection from here, let's see, where was it? Yeah, from here to there is good. and from here to the regulator is good. But now if we follow the trace from here to here, there's no connection. Okay, so this trace on top here is broken somewhere. Okay, and I'm thinking that's why. I mean, this is huge. That's why this thing is not working, because this voltage supplies everything that has to do with this battery and the system startup. Okay, so I think this could be our issue, this trace being broken. So that's the third thing I have to fix here. So let me get working on that, and we'll see what happens. All right, guys. So there's three things we have to do here. We have to drill out this hole with this drill bit right here. Okay, I'm going to use this drill bit to drill out that hole and connect the power to that capacitor from here. Okay. The second issue was this resistor was not connected to the pad. I don't know if you can see, but this pad is pretty much destroyed, so we have to fix that and then put all the rest of the resistors in. And then the most important issue is this via is not connecting to this one. Okay, the trace is broken somewhere, and the unregulated voltage cannot get to this Zener diode here. And that's a problem because this Zener diode controls the startup of this amplifier. So I think that's our issue. I think once we fix that, we'll be good. All right. So I'm going to start by drilling out this hole. Okay, and let me just show you how I do it. All right. So you put the drill bit in and go really slow. Okay. You don't want to go too fast, because if it breaks in there, then you'll have to drill it out with a drill press. All right, and you want to go in reverse a little bit and then go forward until it goes through. Okay, and I think I just felt it go through. Yeah. All right, so that should be good. All right, let me zoom in. All right, so now that we have a hole there, okay, we can take a wire from the other side where it's connected, go through the hole and onto that capacitor. Okay, so now let's work on this pad and putting in the resistors. All right, guys, so this through hole here where the power is supposed to go was unreliable. The connection was iffy. It wasn't perfect. So what I winded up doing is taking a jumper wire, directly from the regulator to this capacitor. Okay, so now we have continuity. Okay, and I had to do that because it turns out that this resistor, okay, the power also is going to that resistor, and so that wasn't connected either. And the other side of the resistor goes right here to the other board. So that's all fixed now. So step one is done. I just ran a wire on top. So step two now is we have to fix this this right here. And there's actually continuity to the pad. So I think all we need to do is put a new resistor on here. I think that resistor was just no good. Yeah, so let me put all brand new resistors in here and this IC. All right, I got the resistors in. Let's see if we have continuity on this one. From the via to the resistor. We do, okay? So that's good. And what about this one? We do, all right? All right, so I think these are good now. These have all been replaced. The only thing I didn't do is connect this Zener diode to this unregulated side of the voltage regulator because the voltage has to get there. I didn't want to use the holes, the vias, because they were too small and, you know, I don't trust them. So I'm going to run a wire from here to there, just like I did here, okay? And I'll connect it up that way. All right, guys. Here's the wire I put in from the Zener diode to the unregulated supply. Now I winded up connecting it to the capacitor instead of right to the regulator because it was easier. I hooked it around the leg of the capacitor. Okay, and right here I put some hot glue to hold it down, and I put the battery back in. All right, so everything is done, and let's try it, and hopefully we fixed it. I'm plugged in, got the speakers hooked up, going through my isolation transformer, and place your bets. I say 5-to-1 odds we got it working. Fingers crossed. Yeah. Works. Well, there you go, folks. We got it working. This thing sounds incredible. I think I'm going to be on the lookout for one of these. So there you go. I'm going to test it some more, but I think it's all good. And let's see if it retains the last setting we were on. Let's turn it back on. It should, if that battery's working, it should go back to the last setting. Yep, 8-time clean tube. That's what I had. So yeah, it's working. Everything is good on this one. All right, I hope you enjoyed this video.